Welcome, everyone. Now we will look at how AI, IoT, and big data are not just tools, but environments that reshape how consumers perceive value. We will explore what recent research tells us about these interactions. We start on perceived value in smart, AI-driven technologies and what this means for the future of CRM. Perceived value is the cornerstone of marketing research theory. It is a trade-off, the get versus the give. In smart ecosystems, the get includes efficiency and well-being, while the give involves money, time, and the sharing of personal data. Value isn't just a price tag, it's the total benefit a consumer feels they receive. In smart CRM, value is thus created continuously, often in the background, through sensors, recommendations, and automation. That creates new benefits, but also new risks, like privacy anxiety and perceived loss of control. So the key question becomes, which factors drive adoption for each technology type? And how can CRM create value while protecting trust and well-being? The big idea is simple. Value is no longer only what I get for the price. In smart ecosystems, value also comes from comfort, reduced stress, trust, and feeling in control. Throughout this chapter, we will connect the results to well-known theories in marketing and information systems. To understand adoption, we use first UTA-UT2. This theory looks at performance expectancy, meaning is it useful, and effort expectancy, meaning is it easy? We also include hedonic motivation, which is the fun factor. Our research shows that for smart objects, these factors are the primary engines of user intention. Second, we use the privacy calculus theory. It's a mental calculation where consumers weigh the benefits of personalization against the risks of privacy loss. In our study, we found that if the perceived value is high enough, consumers are more willing to share data, but they remain highly sensitive to potential data misuse. Third, trust theory is central here. In smart cities and technologies, trust isn't just about the brand, it's about the technology itself. Trust acts as a mediator. If a user doesn't trust the data handling, the perceived utility of the device drops significantly. Fourth, we also apply transformative service research. This theory suggests that smart services should contribute to the well-being of individuals and society. When a smart CRM ecosystem actually improves a user's health and happiness, it creates a much deeper, more sustainable relationship than traditional marketing. Our approach behind the result is research cautioned by high scientific legitimacy. The work is multi-method, EEG, eye tracking, and smart home and mobile AI lab experiments with a total dataset around N5,000. There are also simulated labs for smart homes and autonomous vehicles in Germany, and the broader research has a global scope across Europe, Asia, and the USA. This matters because adoption is not only a tech question, it is also cultural, psychological, and contextual. So we need strong methods and multiple contexts to get reliable insights. For smart connected objects, we studied smart watches and bracelets, sleep apps, mHealth apps, and smart homes. We also looked at Gen AI inside smart homes like energy management and smart fridge recommendations. We used large international samples of more than 2,000 respondents across France, USA, Germany, Thailand, China. For autonomous vehicles, the interesting dynamic is that adoption changes when automation increases. We realized large-scale studies with a real Level 3 semi-autonomous vehicle, as we have seen before, and a Level 5 fully autonomous driving virtual reality simulator. Finally, we used a real autonomous shuttle on the campus of the University of Heilbronn. All studies were realized in Germany with big samples and mostly with situations where we measured before, during, and after usage to understand dynamic changes in perceptions of benefits and risks. In another sector, we tested the perceptions of benefits and risks of different types of robots, chatbots, social robots at home and in restaurants, and then AI-based recommender systems. All the samples are representative, and I realized in different countries, France and USA. Finally, we tested the perceptions of benefits and risks of delivery drones for food and drugs, as well as brain-machine interfaces, BMI, such as Elon Musk's Neuralink. All the samples are representative, and I realized in France. Regulatory focus theory explains how different people react to smart tech. Across all technologies, the results converge on two pathways of adoption. The first is a utilitarian cognitive pathway. The second is a promotion emotional pathway. Let's have a closer look on both. The first is a utilitarian cognitive pathway, where customers ask, does it work? Is it easy? Can I trust it? And is it safe? This pathway aligns strongly with Ch5a, perceived value logic, and risk-benefit thinking. The second is an effective promotion emotional pathway where customers ask, does it make me feel better? Does it fit my lifestyle? Does it personalize to me and my individual needs? Does it recognize me? And does it support my well-being? This pathway connects directly with TSR and well-being-centric CRM. The following two slides frame and detail the core model of regulatory focus theory with the two big paths, a cognitive path and an effective path. The cognitive path is the rational side, performance, ease of use, service quality, as well as trust, plus technology and privacy risk perceptions. Our research details the utilitarian pathway, performance expectancy and ease of use as direct drivers of adoption. This is classic UTA-UT2. If the technology helps me reach my goals and it feels easy, adoption increases. But what is important here is that performance is not always only speed or productivity. Sometimes performance means safety, health improvement, or decision support. For CRM strategy, this means the functional value proposition must be very clear and measurable, especially for technologies that people adopt for practical reasons, like smart homes, autonomous mobility, or service robots in retail. Our research also highlights environmental benefits as an additional utilitarian driver in some contexts. This is important because it adds a moral or societal value layer. I adopt because it helps the environment, but the effect is not universal. Environmental benefits matter strongly for some technologies, like energy-related systems and drones, where sustainability narratives are credible and visible. For other technologies, like chatbots or robots, customers may not connect the technology to sustainability. So the CRM lesson is, don't force green messaging everywhere. Use it where it truly fits the technology and the customer's mental model. Now we see the detailed, standardized, utilitarian pathway adoption factors coming from our regression models as importance percentages per technology, performance expectancy, ease of use, trust, and environmental benefits. The key takeaway is that adoption is composition-based. Each technology has a different mix. Performance expectancy dominates adoption for many technologies, especially chatbots, external robots, and autonomous mobility. Ease of use becomes extremely important in smart homes because complexity is a barrier in domestic life. Trust becomes central for high-stakes technologies like BMIs, home robots, and autonomous vehicles because customers delegate control and accept vulnerability. Environmental benefits matter mainly where the green value is clearly visible, such as drones and Gen AI energy systems. On the other hand, are the negative utilitarian multiple adoption factors acting as a barrier, as risk is not one dimension. Again, it changes by technology. There are technology risks, hesitations about physical harm or technical failures. There are privacy risks, fears about data collection and usage. This is exactly privacy calculus theory. Customers constantly weigh benefits against privacy costs. Finally, there are ethical risks, risk about human replacement, and too much anthropomorphism of AI. This is the prevention-focused side from regulatory focus theory. People ask, is it safe? And will it fail? It also links to trust theory. Trust drops when perceived technology competence and reliability are questioned. In smart CRM, risk management is not only legal or technical, it is also psychological. Customers need visible safety signals, clear explanations, and reassurance mechanisms. Looking at the detailed impact of risk factors of the various smart technologies, we found the following. Technology risks become extremely high for BMIs because the perceived physical and technical stakes are huge. The more intimate the context, health, home, autonomous mobility, the stronger the privacy calculus. Privacy risks dominate in sleep apps, drones, and Gen AI recommender contexts because data feels intimate or sensitive. CRM implication: if privacy settings are unclear, customers may still try the technology once, but they won't stay. Long-term relationship value depends on perceived data fairness, transparency, and user control. Ethical risks appear most clearly for home robots and external service robots, because customers worry about human replacement, social norms, and moral discomfort. This shows why privacy calculus and perceived legitimacy must be part of CRM theory. Customers constantly trade off benefits and risks. This slide introduces the second utilitarian pathway dimension to adoption: service quality. The logic is, service quality does not only create satisfaction, it creates trust, which then supports adoption and continued use. This aligns with classic service marketing theory. Reliability and competence build confidence. In AI-driven services, that trust-building role becomes even stronger because the system can feel opaque. So service quality becomes a trust infrastructure for smart CRM. Here we see the service quality dimensions with standardized contributions for each technology: empathy, speed, competence, reliability, and aesthetics. The big message: reliability and speed are consistently strong, while empathy is technology dependent, especially for chatbots, service robots, and Gen AI recommenders. For chatbots, reliability, competence, and speed dominate. Aesthetics and empathy are small. For Gen AI recommenders, reliability, speed, competence are balanced and equally important. Aesthetics also matters more because the interface shapes comfort and perceived professionalism. Empathy is not the decisive driver there, especially if the task is simple. For home robots, reliability, competence, and empathy matter. Empathy becomes more visible because interaction happens in personal or social spaces. For external service robots, speed is very important, as then reliability and competence. Empathy is nearly absent. So the CRM takeaway is concrete. If you want trust in AI service interactions, your first investment should be reliability, competence, and response speed, not cute design or forced empathy. The key CRM implication is that perceived utilitarian value is extremely heterogeneous according to users and technologies. But beyond that, utilitarian value is not enough to crave value to make customers loyal. The effective path, the emotional experiential side, is very important. Social presence, social recognition, well-being, and personalization value. The key insight is that smart technologies often need both paths at the same time. When companies focus only on efficiency, they miss emotional value. When they focus only on wow effects, they may lose trust. So smart CRM must balance both. So let's have a closer look at the detailed results of our multi-method, multi-sample, cross-cultural research of different smart technologies. Across technologies, well-being is one of the most powerful adoption drivers. It becomes central, especially for smart homes, sleep apps, health apps, home robots, BMIs. But it is important for all technologies. The key message is that well-being is not a nice extra. It reduces technology anxiety, increases trust, and increases adoption intention. In other words, customers adopt technologies more easily when the technology makes life feel simpler, safer, calmer, and more empowering. This perfectly aligns with TSR. Value is not only economic, it is also about quality of life. Personalization also becomes central, especially for smart homes, sleep apps, health apps, smart stores, and Gen AI recommenders. Social presence matters mainly in technologies that interact with humans in a social way, such as autonomous shuttles and robots. Social recognition matters when identity and social meaning as well as community tools are involved, such as smart watches, autonomous shuttles, and drones. The key CRM implication is that perceived utilitarian value is still necessary, but it is not sufficient in smart ecosystems, where perceived value is highly influenced by effective promotion-orientated factors. Adoption increasingly depends on emotional value, not only functional value. The two paths, adoption and perceived value, naturally depend on the cross-cultural contexts. On this slide, we see, for example, how privacy concerns differ across countries for smart home technologies and why this matters for adoption. In Germany, privacy sensitivity is the highest. People see data sovereignty as a fundamental right. They are also more skeptical of black box AI, so they want transparency and control. In privacy calculus terms, the perceived risks often outweigh the functional benefits, so adoption depends strongly on clear safeguards, local data storage, strong permissions, and easy opt-out options. In France, the picture is more paradoxical. People say they care about privacy, but they still use smart home services when the value is high. Trust is often delegated to regulation, especially GDPR, and to well-known brands. This is the classic privacy paradox: concern in theory, but consent in practice. In calculus terms, users accept a trade-off when convenience and well-being benefits feel strong. In China, privacy sensitivity is more pragmatic. Tracking is more often framed as a safety and efficiency tool. People focus more on usefulness and convenience, so the perceived benefits can outweigh surveillance concerns. The privacy calculus becomes: if it improves daily life, the exchange is acceptable. The key takeaway is that adoption messaging must be adapted. In Germany, lead with control and explainability. In France, lead with value plus reassurance through regulation and brand trust. In China, lead with utility and efficiency, while still offering basic privacy options. Our qualitative text mining results reproduce the same dual engine you found quantitatively. People adopt smart technologies when they see clear functional value, performance, ease, security, trust, but they also judge them emotionally: comfort, well-being, personalization, feeling in control. At the same time, two barriers keep coming back in natural language: privacy concerns and fear of loss of control or failure. This aligns very well with Ch5a, performance expectancy and effort expectancy, trust theory and privacy calculus, benefits versus perceived risks, and transformative service research, the idea that technology should improve well-being, not only efficiency. Here, a very large dataset with 185,133 App Store reviews related to smart home ecosystems collected between 2020 and 2024 in the US mirror our quantitative adoption model. The important topics are environment connectivity and consumer smart home interactions. This is a direct qualitative confirmation of the cognitive path in Ch5a. Beyond that, there is a clear service personalization topic. This is important because it validates our effective TSR side. Smart homes are not only tools, they are adaptive environments. People value routines, personalization, and automation because it creates well-being, comfort, convenience, and a feeling that the home fits me. We also found a strong qualitative confirmation of privacy calculus and trust theory. As a major topic is data privacy concerns. Users constantly evaluate whether personalization is worth the perceived surveillance. The key message is, even when smart homes deliver high value, privacy remains a major friction point, and the language of reviews proves it. Our results are confirmed for another technology, mHealth apps. Almost 400,000 e-views about mHealth apps in the US, collected from 2014 to 2020, clearly show how the topics separate health value from technology friction, which matches our quantitative two-path logic perfectly. Well-being, operationalized through concrete metrics, is a very strong value dimension. People do not describe these apps mainly as entertainment or gadgets. They describe them as life-improving tools that support their health goals. Then, user experience terms like design, experience, joy, fun, new. This is important because it shows that adoption is not only medical utility, it is also experience design. If the interface is clear and motivating, the app feels supportive rather than stressful. That matches the idea that perceived value includes emotional comfort, not only usefulness. Then customer relationship terms: customer value, service, company relationship, recovery, trust, engagement, purchase. This is exactly where relationship marketing and trust theory come in. You also see a clear ease of use and connectivity block. Easy to use, Bluetooth, syncing, reset, restart. That is classic Ch5a effort expectancy. It also explains a common adoption pattern. Many people want the benefits but drop out when syncing fails or the interface becomes annoying. Finally, the security privacy block appears explicitly, with words like intrusive, privacy, disadvantage, fear, ethics. This is a direct confirmation of privacy calculus. Users weigh health benefits against perceived surveillance and risk. Importantly, mHealth is a context where privacy sensitivity is naturally high, so the qualitative results strongly support your quantitative risk barrier pathway. In simple terms, mHealth adoption is driven by strong well-being value, but it is stabilized or destabilized by trust, data privacy perceptions, and usability reliability. For autonomous vehicles, benefits and risks confirm the dual model. On the benefit side, people mention performance and efficiency, savings, energy, service. That aligns with Ch5a performance expectancy. Autonomous vehicles must deliver real functional gains such as convenience, reduced fatigue, or improved mobility. They also mention assistance, comfort, ease of use, and well-being. This is crucial because it shows that AV adoption is not only rational. People imagine autonomy as a comfort technology: less driving stress, more relaxation, and more freedom during travel time. This directly supports your effective pathway. Well-being and comfort are part of perceived value. A third benefit theme is security, technology trust, and well-being. This is exactly trust theory. People do not adopt autonomy unless they believe it is safe and reliable. In AVs, trust is not abstract. It is existential. It relates to physical harm risk and responsibility. On the risk side, the slide lists dependence, privacy, data loss, loss of control, and accidents breakdowns. This matches your quantitative risk logic extremely well. Autonomous driving pushes directly on the deepest adoption barrier: giving up control. That is why, theoretically, regulatory focus theory becomes highly relevant here. Prevention-focused consumers react strongly to accident and loss of control cues, whereas promotion-focused consumers respond more to comfort, freedom, and time-saving benefits. So AVs are the perfect case where adoption depends on balancing promotion framing, benefits with prevention reassurance, safety, transparency, control options. So overall, the qualitative results confirm that AV adoption is simultaneously utilitarian, performance, ease, security, and effective, comfort, well-being, but heavily constrained by risk perception and control anxiety, exactly what our two-path model captures. This research analyzes 121,230 reviews about social robots in France and produces 5 nearly equal themes. One theme is openness to new. Users talk about novelty, new experience, different interaction, personal tips. This confirms the effective side. Social robots can create curiosity, enjoyment, and perceived personalization. A second theme is usefulness. Users mention control, customer, physical, fast, waiter. This confirms the UTA-UT2 performance logic. Robots must clearly improve service speed and convenience. A third theme is mixed feelings. Words like weird, comfortable, issue. This is psychologically important. It reflects ambivalence and sometimes mild discomfort. Exactly what social presence and anthropomorphism theory predicts. Human-like technologies can reduce distance, but they can also create unease if the interaction feels unnatural. A fourth theme is human for complaints. People explicitly want a human when something goes wrong. Problem, uncomfortable, damage, fault. This is one of the strongest qualitative confirmations of your service quality to trust logic. Even when automation works most of the time, users demand a human recovery channel for accountability and emotional reassurance. In relationship marketing terms, service recovery is a major trust repair mechanism. Finally, there is job loss and human replacement. Job, money, impersonal, people, care. This is not just a risk perception. It is an ethical and societal concern that shapes legitimacy. It connects directly to transformative service research. If technology threatens dignity, social inclusion, or fairness, it can reduce long-term acceptance even when the functional value is strong. So these results confirm again our quantitative model in a very rich way. Adoption is pulled by usefulness and novelty and pushed back by discomfort, legitimacy concerns, and the need for human backup. In summary, when we combine these qualitative results with our quantitative two-paths adoption models, we get a strong triangulation and solid confirmation of our research.